Figure above, AD and BC are parallel, right? So we know that. And we know, what else do we know? AB is perpendicular to BC, so we know this. And note that if we know those things are parallel, and we know this is perpendicular, we also know we've got a right angle up here, right? AB equals 2. And AC and CD, both equal to root 2. Okay, well, what is the perimeter of ABCD? So here's how we're going to work through this. First thing we need to recognize is that if I've got a 2 here and a 2 rad 2 here and a right angle here, there's only one kind of triangle ABC can be. ABC must be a 45, 45, 90. That's the only thing it can be. And we could prove it with the Pythagorean theorem, but I hope by now you just recognize these things and you don't need the proof. So that's going to be a 2 because this is a 45, 45, 90. 2, 2, 2 rad 2. All right. Now, the other thing that's interesting there is I've got 2 rad 2 for AC. I've got 2 rad 2 for CD. That means that triangle ACD is isosceles. And that means that these angles are the same. Now, I happen to know, because this is 45 degrees, that this is 45 degrees. And that means that this is also a larger 45, 45, 90 triangle. Cool? So 45 degrees, 90 degrees. That means 2 rad 2, 2 rad 2, and this is going to be 2 rad 2 times rad 2, because that's how 45, 45, 90 triangles work. The hypotenuse is going to be the leg times rad 2. Of course, 2 rad 2 times rad 2 is going to simplify to 4. So I know that AD is 4. So what's the perimeter of ABCD? Well, that's going to be 2 plus 2 plus 2 rad 2 plus 4, working all the way around from sort of AB, 2, 2, 2 rad 2, and 4. Add that up, and that is 8 plus 2 rad 2. That's choice A. Cool?